everyone. We're going to go ahead and begin this presentation in just about 2 minutes, just to allow everyone to come in and get situated. All right, hello everyone. Thank you for attending our webinar today. Before we begin, just a little bit of housekeeping. Please note that all attendees will be kept on mute for the duration of the call. For the best audio experience, make sure that you're listening to today's webinar through your phone. And please submit any questions that you may have using the questions feature in the control panel to the right of your screen. A copy of this webinar recording will be shared following today's webinar. And now to get started, welcome everyone to our Sump Design and Mine Efficiency webinar, which will discuss how to design your mine sump with the right pumps, piping, and smart solutions for the most efficient and reliable dewatering system, including planning for future expansion throughout the mine's life cycle. I'm pleased to introduce today's speaker, Greg Asselta, Business Development Manager at Xylem. He focuses on collaborative growth across the entire business. Greg holds a bachelor's degree in industrial engineering from Penn State, and for the past 13 years with Xylem, Greg has been supporting the mining and construction industries, providing him with a wealth of knowledge and configuring reliable solutions for our mining customers to achieve their operational goals.
All right, great. Thank you, and good afternoon, everybody. As Sohini said, my name is Greg Asselta, and I'm the Business Development Manager for Synergy for our Service Solutions business here in North America. And I'm really happy to be here with you today to talk about this important topic. And I appreciate you all taking time out of your busy schedules to be here with me. Again, as Sohini introduced, we are going to discuss sump design and mine efficiency, which is an important topic that affects all mine operations. Coming into this topic, I thought of a quote that I heard from our Director of Sales and Services, Ken Albaugh, and he said, and I'm probably paraphrasing here, but in a mine site, water is one of those things that sometimes you have too much, sometimes you don't have enough, sometimes you have the wrong quality, and sometimes it's in the wrong place. You know, water management on a mine site can affect many parts of the operation, from public perception to regulatory compliance to operational profitability, and even to the overall quality of the product being mined. So proper sump design and utilization can have a direct impact on those considerations and on the overall success of your mine operation. I'm actually going to go off screen here so you guys can pay attention to the presentation. So let's start with a brief overview of Xylem. If you're not familiar, Xylem is a multinational company We did over $8 billion of revenue last year in 2023, and that was supported by over 23,000 water professionals around the globe. We operate in over 150 countries. Our mission is let's solve water. And by that, we mean helping our customers solve their critical water challenges, whether it be, again, too much water, not enough water, or managing the quality of water that they have on their sites. This has been our mission for the past 13 years with Xylem, and we look forward to continuing for many more years to come. A key part to this is having a trusted partner to help with smart water management. You need to have a partner who understands your operation and your unique challenges and will support you beyond just selling necessarily a pump or a pipe or an additional gadget here or there. You want a partner who will take a broader, more holistic view on how water is being utilized in your operation and support you in making improvements with products and services that will enable efficiency gains. Each mine site is unique. We appreciate standardization and best practices within an organization, but we all know that at an operational level, no two mine sites are exactly alike. And with that comes unique challenges that require specific solutions. And our expertise is rooted in years of experience, not only in the water equipment, services, and solutions space, but also with leaders and sales and service professionals who have direct experience from the mining industry. So how do you identify and evaluate the correct partner? First, I suggest you look for a company with a large portfolio. And not only a large portfolio, but the ability to service the entirety of your needs. If we look at Xylem, you'll see some legendary brands that are known worldwide, from pumps to treatment to monitoring and analysis. We really cover the whole water space very well. We feature mining professionals, as I mentioned, with a lot of experience in the field, working at mines directly. And these water professionals are available 24 hours a day, 7 days a week. We know that mining doesn't stop, and neither do we. And we're here to support you. The next we like to focus on is a digital presence. Digital tools are going to help you monitor and control equipment, but also optimize your system performance. And finally, we really like to focus on our technical and engineering expertise that helps you to optimize and improve your operations. So let's get into the meat of today's presentation about sump design and mine efficiency. First, we're going to start talking about the importance of sump design and some of the considerations and best practices that would go into proper sump design. We'll do a little bit of a comparison, looking at some real life sumps with a good and better sump design conversation, and finally go into some case studies with some examples where we overcame some customer challenges, helping them to solve problems within their existing sumps. And finally, we'll talk about the value of partnering with Xylem as your mine water management solutions partner. So let's start with the importance of proper sump design. Pumps and sumps are critical pieces of a mine operations infrastructure. Having spent time with many mining customers, I've often heard that dewatering and pumping is a nuisance activity, a necessary evil. However, we prefer to view it that a well-designed dewatering system enables efficient mining operations and production. And that starts with the sumps, their designs, and their location. When optimally designed, sumps can help extend pump life. They can help avoid clogging of pumps and reduce abrasive wear, leading to reduced performance of that pumping equipment and potentially even failure. Nobody likes to respond to a break fix situation. So we help to avoid the need for emergency response call outs late at night. Nobody likes that call, after midnight that the pump is down and we need something fast. Proper sump design lowers the cost for dewatering activity by making it as efficient as possible. It helps prevent groundwater contamination or flooding, right? So it's better for the environment and regulatory compliance. We provide a safer working environment for your personnel by reducing hazards and allowing for operational uptime and more productive mining. Again, proper pump and sump design enables a more reliable and profitable mining operation. So here we have a couple common challenges that we come across in sumps. The first you can see here is sump cleaning has been neglected. Mine water, as we all know, is laden with small particulate that can ultimately build up and eventually result in clogging of pumps, reducing performance and even potential failure of that equipment. There are other things like shotcrete that's used for ground support that the little fibers, can get into those pumps and cause clogging or even premature wear, and eventually failure. We talked about wanting to avoid break fix incidences. And finally, snore control is not correctly set. So essentially, the pumps are either running continuously or starting and stopping too frequently, eventually leading to a lot of failures. So these are some of the challenges that pumping equipment sees that really relate to the sumps themselves and how they're maintained. So here on the screen, you're going to see some of the considerations for best-in-class sump design, and I'll touch on a few of these here. You can obviously read through, but talking about some of the highlights: sediment and debris. As I mentioned, mine water is going to have small particulate in it that over time will collect at the bottom of the sump, which could clog pumps, restricting their operation and reducing sump volume and efficiency. Proper design should include features to manage and even remove those solids, or at the very least, prevent additional solids from entering into the pumping equipment. Location and access. You heard me talk earlier about the water is sometimes in the wrong place. Well, I take that to mean sometimes the sump is in the wrong location. So it's really important to strategically locate sumps to collect water from the lowest points of the mine, right? Let's not try to fight gravity. Start at the lowest point of the mine to start our dewatering pumping process and system. In addition to the location, accessibility for the maintenance and upkeep. That could be maintenance and upkeep of the sump itself for inspection and that sediment removal that I mentioned earlier, but also access to enable the servicing of pumping equipment, making sure that it is operating at its optimal, most efficient points. Regular pump maintenance. This is a near and dear to my heart, but choosing a partner that really understands water management and has offerings that support preventative maintenance, has temporary pumping equipment available through a rental fleet, or even entering in long-term service agreements to make sure that pumping equipment is available, but also having service professionals come on site and perform service and maintenance to the pumps, again, to keep them operating at their best efficiency and optimal operation. Finally, water storage. Putting a water management strategy in place that will allow water that's already being pumped out and out from the active mining areas, and evaluating can that water be utilized elsewhere in the operation. There's a lot of opportunities for reuse of water, and we'll actually talk a little bit about those throughout this presentation. Those are just some of the considerations that we like to highlight as far as sump design, and really like to make sure that these are being considered. getting into some of the comparisons, good versus better sump design. Here we are looking at two sumps in an underground mine. We'll start with the sump that you see on the left. Essentially, what you can't see in this image is that the sump actually opens up to the left and right below the pumps that you see in the middle of that photo. While there are some positives about the sump design, including, it's in an open, accessible location. The equipment there is properly sized. That's featuring two 300 horsepower motors on vertical turbine pumps. There's good overhead lighting, right? We're underground, it's dark. We want to make sure that we have adequate lighting to enhance the safety for our personnel as much as possible. But there are still some safety concerns here. We do see the hazardous area sign on the chain going across the screen and a life vest hanging there, but there are still several trip hazards with the way that the discharge piping is laid out. You can see some partially buried pipes that would be hard to identify, especially when you're holding tools or looking at the pumping equipment that you're looking to service. There's power cables hanging right above those pumps that really could be managed in better ways. So there is, opportunity for some improvements in how this is laid out. It also appears that there's some water spraying from the pump on the left, likely relating to the need for changing the seal packing. And you need to understand how difficult working on these pumps would be for your own personnel or for a service provider coming on site. Safety is always our first concern, right? People are our most important resources. So giving them an environment that is as safe as possible in which to conduct their important work is very, very important to us. Now, switching our focus to the sump on the right. Again, we have something that is very open and accessible as far as location. There is good overhead lighting again, and we can see some improved site safety considerations. This is essentially a better layout. There are some clear walkways with brightly colored railings. There's a flotation device readily available hanging on the left wall. And also you can see on the image on the lower right, it's a little hard to see looking at the walkway picture, but the image on the lower right is kind of looking over that railing. You can see the submersible pump there is suspended from the ceiling by a chain. It's low enough that's going to keep it submerged and operating, efficiently in the water that's pumping, but it's high enough to keep it off the bottom of the sump and avoid the sedimentation there. So that reduces the risk of clogging and accelerated wear to that pumping equipment. So while the sump on the left is pretty good, the sump on the right, we would say, is better. Let's look here at an open pit sump. Here we see a collection pond, which is essentially a very large sump, right? Water here is being collected, and the water, the vertical turbine pump that you see on the red barge is feeding that water to the washroom. I spoke earlier about water storage as a design consideration. This sump is properly sized to make good use of the water that is being removed from the mining pit by using it to feed the main processes of the plant. It also has extra capacity to handle additional inflow from potential weather events, heavy rainfall. The equipment is properly sized and supported on that red barge with plenty of safety precautions like handrails, non-slip grading, well-managed electrical cables, basically providing a good space for a service professional to come and evaluate, service, and maintain that pump when necessary. And although it has limited direct access for sediment removal, we know this sump is largely being fed with clean water, so sedimentation is less of a concern. But as you can see on the image on the left, there are very wide roadways that were designed wide enough to support some long stick track hose that can essentially reach in and do some cleaning of the sump when necessary. Overall, we would consider this an excellent sump design. So getting into some case studies. First, we're starting with this coal mine in Indiana. Essentially, they had a very difficult challenge needing to pump water from its underground mine that had a lot of solids. In addition to that, being underground, there was a very small area in which to work and put these pumps. There was a mine void that was less than 8 feet high with a narrow 20-foot entryway as its access point. With lots of solids, there was constant wear and tear on any existing pumps. And additionally, this customer sought to reuse that water, to filter and treat the water so that it could be reused at its wash plant. Having had success with Xylem dewatering solutions at another mine location, this customer reached out to Xylem yet again to help solve this difficult challenge. And the solution, was multi-steps. First, they installed some custom sumps at various low points to collect the raw water using some MSHA-approved flight submersible pumps in the 2 horsepower range. The water was pumped to the main sump. That was the area with the low ceiling clearance. So next, 2 7-stage Gould's water technology vertical turbine pumps were fitted with 90-degree right angle, high efficiency 200 horsepower motors. The right angle motors enabled their installation by reducing their height due to that low ceiling clearance that I mentioned. Those vertical turbine pumps delivered 1,000 gallons a minute up over 560 vertical feet to the surface to a mixing chamber. Once in that mixing chamber, another small vertical turbine pump moved that underground water that was diluted with some fresh water to a filtering site and next to a settling pond for storage and to allow some of those solids to settle out. From the settling pond, another flight submersible pump on a floating barge, custom built for this application, then pumped essentially that clean water to the wash plant as designed. And the result, years and years after this installation, the system continues to perform effectively, demonstrating the long-term reliability and efficiency of the solution. This has saved the customer from numerous headaches, as well as expensive man hours in sump and pump supervision, maintenance, and repairs. For our next case study, a mining customer in Peru basically discovered copper was deeper in their open pit mine than they had expected. So they had to continue to dig deeper to access that valuable resource. They were going beyond 1,200 feet below the surface. And they knew that in the summer months, an excess of water from that rainy season made it more difficult to manage the level of the water at the bottom of the pit and made it very difficult to operate the pump, which originally had a switch located deep within the mine. Since their mine personnel needed to go down into the mine to turn on or turn off the pumps, there was additional safety concerns with going into the mine with electrical cable management, as well as active mining and the use of explosives as they continued their operation, going deeper and deeper. So the solution, due to the electrical power concerns at these distances, it was actually decided that a diesel pump was the best solution here. 3 Godwin HL130M dry prime pumps were mounted on trailers and brought down into the pit. With the diesel pumps, the electrical cables were no longer a concern, but the depths of the mine meant that somebody would still need to go down into the pit to operate the pump. So the pumping equipment was fitted with a solution to remotely start and stop the pump, as well as monitor flow and even fuel levels within the pump. The remote system was then integrated into the mine's existing SCADA system for them to make sure that they are using it as easily as possible. And the result here, the remotely operated system greatly enhanced their safety for their personnel and reduced operational expenses by minimizing the exposure of pumping equipment to the active mining environment and reducing personnel's exposure to that equipment as well. All right, our final case study. This one is a quarry in northern Quebec essentially they faced significant issues with ice formation in their primary basin during their very, very cold winter months. You can see during those winter months, temperatures could reach as low as 40 degrees below 0 Celsius. The basin here was about 100 feet by 80 feet wide and 40 feet deep. And the freezing that they were experiencing led to frequently broken pump cables as well as bursting pipes. Between fixing broken pumps and pipes and renting temporary equipment to break the ice, they estimated $25,000 spend each winter to maintain pumping operation in this basin. And that doesn't include the many hours of their personnel required to devote time to overseeing repairs, as well as the safety concerns of having to actually free the pumps from that icy basin. So working with Xylem, a solution was identified that we could reduce ice formation by keeping the water circulating. With warmer water moving from down near the original submersible pump that was in the basin, ice could no longer form around the power cables. A 40 horsepower Flight 4680 compact mixer was fitted with a cement base, and the quarry personnel actually prepared a metal catwalk to where that mixer would be lowered near the dewatering pump. And as a result, once the mixer was installed, the ice problem stopped. There was no more downtime on the pumping system. The customer saved considerable money by avoiding expensive repairs and power cable replacements, and no longer needed ice breaking equipment to be regularly rented each winter. And most importantly, the safety concerns were greatly minimized by reducing the exposure to this icy basin. So what are some of the key aspects to mine water management? Every site has its own unique challenges and differences that we take into consideration. We handle everything from installation and commissioning to ongoing service support and maintenance. Whether it's daily operations or dealing with temporary equipment needs for weather-related events, we've got you covered. We're here to provide tailored solutions that fit your specific needs. And we always encourage you, the earlier that you get us involved, the better we can help design the optimal system for your site and your applications. Our commitment to you is that we are here to help you achieve your water management goals, and we appreciate the opportunity to do so. So please reach out and we can get to work together. Thank you.
Thank you, Greg. We've been collecting your questions throughout the presentation, and we'll spend a little bit of time now answering as many as we can. But before we get started, let me remind everyone that if you have a question, please submit it using the questions feature in the GoToWebinar control panel. It's typically located to the right of your screen. So I'll go ahead and jump into the first question that we received here, but please continue to input your questions for Greg. So our first question comes from an attendee that has an issue on their mine site. They have one sump that burns up pumps constantly. They're underground and there are no plans to update the sump. Do you have any recommendations that they could implement quickly?
Well, that's a great question. And yeah, there's certainly a few ideas that come to mind. If your pumps are clogging, then you're likely running at full speed with little or no flow. If it's a submersible pump, then typically you're relying on pumped water to help cool the motor. So without that flow of water, your motor windings could be overheating to the point of failure. Obviously, we would recommend cleaning out the sump to remove any built-up sedimentation, and look for ways to reduce sediment buildup in the future with either a settling tank or additional screening. But a quick fix could be to suspend the pump so that it's not sitting down in the muck at the bottom of the sump. This would help improve the longevity of the pumps in that application. If it's not clogging, it could be an indication that they're operating basically too far out on their performance curve. Too much flow, not enough head. Once they start, or if they're starting and stopping too frequently, the motor, or even snoring. Snoring will lead to increased heat without the cooling of the pump fluid, as I mentioned, with clogging. And this could be an indication that the sump levels controls are not correctly set or not being utilized at all. Quick fix here could be utilizing a VFD to ensure that the pump is operating near its BEP or best efficiency point. Alternatively, I would say we do have some newer technology that could help. The Flight Bebo Alpha is a submersible drainage pump with an integrated drive that optimizes the pump speed as it detects when the pump is under load and should be pumping, or when it has entered a snoring condition, or pumping with little or no water, at which point the pump automatically slows down to a very, very low RPM until it detects more water. If you are already utilizing a flight submersible pump, we also have the Pareo control system for smarter drainage pumping. This is an external control system that similarly monitors the pump motor to detect when it's under load and will continue pumping, or when it's not under load and will shut down the pump to avoid snoring. I would say, if you would like to reach out after this webinar, we can certainly help evaluate your specific situation and develop recommendations best to optimize your existing sump and pumping system.
Awesome. Thanks, Greg. Another question came in. Can you please go over how the UG coal mine handled the silt being pumped to the sump before pumping outside through the turbine? And what technical sump design they utilized in creating the sump underground?
It's a great question. So the first thing, as I mentioned, there was custom sumps that were strategically fabricated and located at the low points where water was collecting. The fabricated sumps helped to mitigate some of the sedimentation that was being experienced in just a traditional in-ground sump. The flight MSHA pumps that were utilized in those sumps have hardened impellers, so they were able to handle some of that silt and sediment that was being experienced. It was actually more upstream. The larger vertical turbine pumps that were in that smaller mine void, kind of the main sump, were fitted with some duplex stainless steel materials and special coatings to help it withstand the sediment a bit better. So it wasn't necessarily that the silt being pumped was removed before pumping outside, because once it got outside, it was when it was pumped to the mixing tank and ultimately into the settling ponds, where most of that sediment was being removed before it was being pumped over to the wash plant.
Awesome. And then the next question, can you please go over some wear wall designs and ways that can be blended with clean out of silt using equipment?
I'm sorry, can you repeat that one, Tony?
Can you please go over some wear wall designs and ways that can be blended with clean out of silt using equipment? I think they mean like those lower dams.
The lower dams. Wear wall designs. Yeah, I'm sure that we can. I'm not sure that I'm picturing the question correctly. Is it possible that you could reach out and we could answer that question more directly?
Yeah, definitely. We'll go ahead and move on to the next. How would Xylem approach a dewatering scenario where a significant rain event causes waterways to flood into an open pit, filling the pit with fish, turtles, and other wildlife?
That's a good question. There are certain things that we have utilized to protect wildlife like fish and turtles from entering into pumping equipment. We do have fish screens that we can include into our temporary pumping solutions. Basically, it's a filtration, or rather a screening system, just to make sure that those animals are not getting sucked up into the pumps and pumped out themselves. The removal of those animals and additional silt from the sump after the rain event would be handled externally, but we could certainly assist in that. But I would say if that is a concern, then the addition of some fish screens would be a quick way to protect the pumping equipment from the animals, or rather protect the animals from the pumping equipment.
All right, great. And then another question came in. If the submersible pump's mechanical seal failed more frequently than usual due to solid sedimentation, what would you recommend, or is there a better mechanical seal option?
I would say we should evaluate what your existing seal configuration is. In some cases, it could be, as you mentioned, different materials. For instance, a tungsten carbide has a little bit more hardness than maybe a silicon carbide. So that has better abrasive resistance. It's hard to implement flushes that you might see on surface mounted pumping systems, seals into a submersible seal, just because it is such a integrated system with pump motor, bearings, and seals. I think that, if upgrading the materials of the seal were not sufficient to manage the material being pumped, then the next step would obviously be to evaluate how to reduce the amount of sediment that is needing to be pumped. And that could be, like we mentioned, suspending the pump, either hanging it from a ceiling if it's underground, or using a floating barge system, but basically trying to keep the pump above the heavy sedimentation at the bottom of a sump.
Thanks. One more question. Can you discuss the recommended sizing of an in-pit sump design?
Recommended sizing. I think that there would be a few considerations there. Obviously there's going to be an expected flow of water from what your ground surveys might have indicated, but you have to take into consideration a little bit of a safety factor, knowing the weather in your area and the likelihood of any major rainfalls. And also, there is unexpected water underground that could be encountered. So really, depending on what size area is available for a sump, and comparing that to the necessary flows that are expected with an additional safety factor. So it's not a straight answer there, but just a couple of the considerations that we would take into account as we help to make a sizing recommendation for a sump.
Could you discuss the advantages of submersible versus suction type pumps in relation to sump design?
Sure, yeah. So there's definitely benefits to each. I would say submersible pumps are nice in that they can obviously go into the fluid itself. They don't typically require additional infrastructure. If it's a well-maintained sump, it could properly, it could set on the bottom of the sump. Although, we are seeing a lot more applications where they're floating the pump, again, to help reduce the concerns of clogging. But, it's a all-in-one unit with the motor, the pump, everything is compact and is not going to leak. Whereas, a vertical turbine pump or a surface mounted pump gives you the opportunity to kind of work on different parts of the pump and maintain the motor separately from the pump end if necessary. If the question was specific to vertical turbine pumps, we see a lot of the difference in the size of the pumping application. If it's really high flows or really high head requirements, vertical turbines probably are going to be more beneficial because we can add stages that add pressure or add that discharge head capability versus a submersible pump, which is typically a single stage, in some cases a two-stage configuration. So I would say that there's some limitations on the flow and head capabilities of submersible pumps, whereas vertical turbines are a bit more configurable to handle higher flows and certainly higher heads.
Awesome. Thanks so much, Greg. Kind of seemed like the questions slowed down. So just want to reiterate, thank you everyone for your questions. If you have any other questions following the conclusion of this webinar, please feel free to contact Greg or your local Xylem sales representative, and we're always happy to help. But thank you everyone for attending today's webinar on Sump system design for operational efficiency. Please note that we will be sharing the recording. We will also be hosting one more webinar that will explore the topic of hard rock mining, treatment and service for your mine on September 12th. The registration link for this will be sent in our post-webinar email as well. So on behalf of Xylem, Greg, and our organizers, thank you all so much for joining us today, and we hope you have a wonderful rest of your day.